One. Yeah, first, thank you, Gayatri, for inviting me over. And today's session, I'm going to walk you through a live competition, which is WITS Datathon. Gayatri is also WITS ambassador.
Yeah.
So I thought it might be more relevant. This is an ongoing competition. So you guys can give it a shot as well. It's a live competition. So this year's data set is also a very interesting problem. It's an ML problem for social cause. They're dealing with climate change and how you can use AI and machine learning to combat problems around climate change. So this the data set we are given the specific problem in climate change we are dealing here is estimating the electricity consumption in buildings. And why is electricity consumption very much important? So if you see there is a correlation between the electricity consumption and the amount of carbon dioxide which is released in the atmosphere. So if you can control the electricity consumption by buildings, or it might help in minimizing or almost around 37% of the carbon dioxide emissions. There is some kind of a statistics. I'm not sure if 37 is the right number. And so that, if you can estimate, make a very good predictions or forecast the energy consumptions of buildings, and then you can find out what is causing the higher energy consumption, and you can work your way around it. For that to happen, we need to understand how the energy consumption works. So what kind of buildings consume more electricity, and what are the factors which actually contribute to the higher electricity consumption. So there are a lot of research papers out there which say weather is very much important topic in electricity consumption. If your weather is very hot, then you might end up using a lot of AC, and that might consume a lot of power. And again, if your weather is extremely cold, then you might end up using heater, and that might also cause more electricity consumption. This is what our traditional beliefs are, and this is what a lot of research paper says as well. But surprisingly, the data set, when you start analyzing using machine learning methods, what we find out is whatever the research says and whatever we are thinking may not actually be true. Let's delve into the data set and see what's happening when you start analyzing using machine learning. And we are given, if you see this WITS datathon, the data set we are given has both building characteristics, and it also has weather related characteristics. So if you see the building characteristics, there are factors like year factor, which year the building was built. So if it's going to be a very, very old building which was built long, long ago, then there's higher probability the building might not be well having a very good infrastructure, and with the lack of infrastructure it can end up in consuming a lot of electricity. So the building characteristics, it's mostly about the energy star rating and what kind of facility. Is it a mall or is it as a residential building? So if it's going to be a mall, then obviously malls will consume a lot of electricity because the number of shops in the malls are huge, right? So, and how big if it's going to be a mall, then it's going to be huge as well compared to a residential building. So what kind of building is it? Is it a school, or is it hotel, or what kind of facility type it is? How much is the floor area, and when was it built? And all these building related characteristics are given, and how much of elevation the building is built in addition to these building related characteristics, we also have weather related characteristics. That is, you have the minimum temperature, you have maximum temperature, average temperature for each of the months. And you also have the other details like snowfall, wind directions, and all. So these I would roughly put it as number of days it's below a certain temperature, number of days below it's a certain above a certain temperature, and all that. So these are the weather related characteristics. So these are the features which are given in the data set. So what we are supposed to do is, we are supposed, using these features as input, we are supposed to predict how much of electricity will be consumed. So this is the problem statement. You have building related characteristics, you have weather related characteristics. Given these input features, you have to find out how much a building is going to consume electricity. The variable that for that is site underscore EUI. In this competition, and site underscore EUI is the target variable. And the next up, I'll just briefly walk through an end-to-end baseline solution for this particular problem statement. If you are a beginner to machine learning and if you're not able to understand a certain parts of it, then it's completely okay. The notebook is a public notebook and the session is recorded as well. So, you can watch it once again. So if you're an absolute beginner learning machine learning for the first time, then it could be a little bit of overwhelming. But don't worry, it's normal. So I'm going to use Light GBM module, which Light GBM generally performs really well in most of the structured data problems. It generally gives, and there are a lot of winning solutions with LGBM as well. But what I'm doing here is a very baseline solution walkthrough. So first step in any building model, you are going to import all the packages. So I'm going to use a scikit-learn version. So I'm going to import scikit-learn, and the Light GBM module is from Microsoft. And I'm going importing that model as well. And so the first step in solving any problem is importing all packages, which is done. Then I have three files. One is a train file, test file, and the submission file. The submission file generally contains how you are going to make sum. This is a Kaggle problem. So in Kaggle, you require to submit submissions in a certain way. So submissions.csv will actually contain the format in which you should submit to Kaggle. Then you also have train and test CSV. Train is the training data and test is the data which you need to test on. And you're going to do head on it, you will have all these features. So as I already told you, whether in building related features, you should use it in order to estimate the target variable, which is site underscore EUI. Site underscore EUI is the amount of electricity which is being consumed. So this is the input feature and this is the target variable. So if you clearly scroll through these variables, you can see the values it takes as well. Except for three features, all of it is numerical. So the three features which are categorical are the state factor. So the states are anonymized. So they've not, see, it's very important, you should anonymize the data. So the states here is anonymized. So they've just said state one. What is the name of the state one is not given. It's just anonymized as state one, state two, state three, state lab to 11. And you also have two types of building class. One is the commercial and residential. Again, this is a categorical variable. And you also have multiple facility types as well. So the first step, what you do is any data analysis, what you will do is you'll find out if there are going to be any missing values or not. We're going to do the same. Let's take the training data set. We'll do a quick heat map to see heat map visualization and to see if there are going to be any missing values. So I can see some pink patches here, which means there are a few missing values. And on a closer introspection, I'm able to find out that there are around 6 features which has certain number of null values in it. It's always a good practice to find out how many null values your data set has. And if there are a lot of null values, you need to do a certain pre-processing to remove these null values. There are a lot of pre-processing techniques out there to remove the null values because your model may be quite inefficient and may not be that accurate if you build your model with null values. Some models will show you outright error. Some models are capable by themselves in handling it. But it's recommended to follow the standard procedures to drop null values. We'll be covering that a little later, but for now, I'm just pointing out to how many fields have null values and what is the null value count. And it's also a good practice to first step in analysis is checking the null values, and then the next step is to quickly do a descriptive statistics on your data set. For each of the features, what is the mean value, standard deviation, minimum value, and all these descriptive features will get you a good idea on what kind of data set you're dealing with. And you will also be dealing with target variable description. So the target variable is site underscore EUI. So site underscore EUI is the amount of electricity which is consumed by the building. So you need to find out how the target variable is distributed. And so the target variable varies between 0 and 200, and above 200 it's almost a outlier. So it is even a box plot will point you out to the outliers very easily. So either you can try a histogram or a box plot for it. And outside the target variable distribution, you should also start analyzing the numerical variables and the categorical variables. So I have already told you the categorical variables, there are only three of them. So the most frequently used kind of plots are the, count plots or the frequency plots for the categorical variables. For the numerical variables, I generally recommend that you try out the distribution and train and test data set. I'm just doing a very basic plot analysis, but there are lots of plots available which you can try it out. I've also written a second notebook which deals with the other possible plots. But for this beginner level session, I would restrict it to basic, distribution plots. But I'll also point you to the link to my second notebook, which has the other advanced plots as well. So this for all the features, I have your. So I have around 63 features. For all of these features, I have the distribution of train and test. So you can see if the train and the test data has a similar distribution. And, you can do those analysis. For all the numerical part, I've just did a KDE plot, which will give me how the data is distributed in training and how the data is distributed in testing. And this is categorical variables. There are three categorical variables. As I told you, state factor. State is an anonymous. We don't have the names of state. Here we have anonymous variables. And we have the count plot of the anonymized state variables. And we have frequency class. So we have more number of records for residential buildings compared to commercial buildings. And we also have more number of records for one kind of facility type, which is uncategorized. And so this is a frequency plot for the categorical variable. So now we have dealt with how we have a basic understanding of the distribution of variables. We will head on to the pre-processing of the data set. So the first pre-processing would be to deal with missing values. So to deal with missing values, there are several techniques out there, but I'm going to deal with the basic techniques because this is a simple baseline walkthrough, notebook walkthrough. So one of the most commonly used techniques is mean imputation. You can also do median imputation, or you can also do log transformations. There are several possible ways which you can impute the missing values. So for the sake of simplicity, I'll restrict it to the mean values. So mean imputation means you're going to fill the missing values with the mean values. So for all the missing fields except here, I'm going to impute it with, replace the null values with the mean values. So this I'm doing it for training data and test data. Except for the year built, I'm doing a mean imputation for all other variables. For the year built, I'm just replacing it with 2022, but then you can replace it with any of the years. And after the first step in pre-processing is missing data imputation, and the next step we also have label encoding. So what is label encoding? We have three categorical variables, and the machine learning model cannot understand categorical variables. It has to understand, it will understand mostly the numerical variables. So you have to come up with a technique to convert your categorical variables to numerical variables. One of the technique available is label encoding. There are several ways, again, you can do it. Then I'm just sticking to the basic step, which is using label encoding technique. You can convert your categorical variables into numerical variables. So this is not a complex bit of code. There's scikit-learn implementation for label encoder is there. So you just have to import the scikit-learn version of label encoder and call the constructor. This will create an object, and you just have to call fit transform on that object to do a label encoding for the particular field. So there are three categorical variables. So I'm doing a fit transform on all the three variables to create my label encoding. And now label and coding, I can convert my categorical variables into numerical variables. So I'm just doing the two pre-processing techniques. One is imputing the missing values. The other is converting the categorical variables into numerical variables. And the third pre-processing is going to be feature scaling. So why do we have to do feature scaling? So if you take the features here, if you take the features here, and all these features, they have different scales of data. For example, floor area has a different scale, year built has a different scale, and energy star rating has a different scale, temperature is measured in a different scale. So each of these fields has different scales. So it's very important to bring all these fields into a unified scales, and that's why we go for feature scaling. So again, feature scaling is a process where you bring all. You can do either standardization or normalization. We're going to do standardization here. Again, it's going to be a scikit-learn implementation. I'm going to import the corresponding functions, APIs, and then I'm going to call a fit transform on it to do the process here. So scikit-learn is a very handy package to do a lot of pre-processing with just few lines of code. And once I do feature scaling, all my values will be between 0 and 1. And the mean will be centered around 0 with standard deviation of 1. So all of the values will be brought to values between 0 and 1. So once I do feature scaling, my pre-processing, I'm going to stop here. There are a lot of pre-processing techniques you can follow it up with. But for the sake of simplicity, this is a very basic notebook walkthrough. So I'm just doing a few techniques. So there is, next up, we're going to build a model using LightGBM. LightGBM is a model from Microsoft, tree-based model from tree-based boosting model from Microsoft. And it's always known to give great accuracy. So to build LightGBM, all this model has got a lot of parameters. So one of the important step is hyperparameters tuning, and there are a lot of open source packages to do hyperparameter tuning, which means finding the best values for hyperparameters. So Optuna is one such open source package which will help you find the best parameters for your LightGBM module. So I'm going to import the Optuna package, and then there is a corresponding method for an Optuna for LightGBM, which is LightGBM tuner CV. And I'll pass the parameters which I want to tune, and it will give me the best values for all these parameters. And using Optuna, I found out the best values for the parameters which I'm going to use in the model. Once I get the best values of these parameters, I'm going to head on to my machine learning model, build a LGBM module, and give the values whatever Optuna had given me as the hyperparameter values. And this is how you build a LGBM model. LGBM is generally used in many winning solutions of Kaggle competitions. It's a gradient boosting framework, and it has a lot of advantages as well. And then gradient boosting has got one important feature, which is you can find out what are the important features which actually contribute to the output. So you have certain top features which actually contribute to the output. It is actually found out the building related characteristics have a huge impact on the building amount of electricity consumed, particularly the topmost feature which is actually predictive of the electricity consumed is facility type. And you also have SHAP values. You can either use feature importance feature of LightGBM, or you can use SHAP values. It will also give you the features which actually give the best predictions. And we are almost done. So you can recreate your model using only the top 10 features to get a best accuracy. And once you are done building the model, you can do predictions on the test data and convert that into a data set CSV file and submitted to the Kaggle. So this is an end-to-end walkthrough, quick end-to-end walkthrough of WITS Datathon. I've also recorded a video for the WITS Datathon tutorial, which you can find it on the tutorials page. So this is going to to be one tutorial here, energy consumption prediction, which is just a repetition of whatever I did now. Just in case you want to rewatch it, then you can head on to the tutorial section and watch the second last video here. And now I'll tell you how to make submissions to the CSV file. You just have to go here, click on submit predictions, and you have to upload your CSV and click on make submission. This is how you will submit predictions to the CSV file. And so I have also made some supplementary tutorials which has the additional walkthrough of few of the EDA, and I've also tried a research paper implementation here, which you can go through. So this is about end-to-end walkthrough of the model, and additional additional data analysis and a research paper implementation is given as well. So this is about WITS Datathon. It's an ongoing competition, and there are a lot of prize money involved as well. You have cash prizes, and there's also phase 2 of the competitions, which is the research paper award, where you can join teams and form teams and publish research paper. This is also a great opportunity. And so I would highly recommend get started with the Datathon. You still have 22 days to go, and it's a huge opportunity for people to feature on the conference. Your name will be called out in the conference. There will be interviews with the winners, and all of it will be publicized from the WITS Stanford official handle. So it's a great opportunity to participate in the hackathon. In addition to this, I'm also hosting something called ML Olympiad, which is a community prediction competitions. When you click on competitions, you will have community predictions competitions. See all. You can just search for ML Olympiad. And there's an ML Olympiad on, autism prediction challenge. This is hosted by me. And this is also a competition which is sponsored by Google developers. And I would highly recommend going through this competition, because the winners will be getting prizes from the TensorFlow team US. And so you will feature in the Twitter handle. So this is actually sponsored by Google developers only, and this is a very basic competition. So you have only 70 teams, so it is not a very competitive competition. So if you're an absolute beginner, compared to WITS Datathon, this may be much more easy, because there's not much of competition, only 17, 20 people, and it's easy to, you can form teams max of 3 size, and you can easily win one of the first 3 prizes. And you will get swags and goodies from the TensorFlow team itself, and it will be shipped to you directly, sponsored by them. And you may also feature in the Twitter handles, and so it's a prestigious option. So give it this shot. And this is about the autism prediction challenge, which is an easier competition compared to WITS. And so give this also a shot. And one more thing, if you're an absolute beginner to Kaggle and you want to get started with Kaggle, then that I've also made a video on how to get started with Kaggle. It's again a part of WITS Datathon resources, official resources, which is tutorials and resources video. Getting started with Kaggle is also there. So if you're an absolute beginner to Kaggle, you can head on to the resources section, and energy consumption score of 52.199. So this is one competition. You still have 21 data set. Then you can also head on to ML Olympiad. again from my this competition, any of the competition, for all these competitions, the first 3 prize winners are sponsored by Google developers, and all of this is hosted by these the TensorFlow user groups across the world. So this is all of it is basic competition. So if you find the other casual competition very overwhelming, this is a great opportunity for you to attend. So this we have come to the end of the session, and I'll open up for questions if there are any. Some of the shortest way to learn is you can take up some courses in Udemy, or you can also take up data camp also has got very well structured course. These are two courses which I have learned, and Coursera also has a lot of courses, but there are too many courses and it might be a little overwhelming. I personally prefer Udemy and data camp because they have like tiny modules and crisp and short. But again, it's up to you. If you want too much of mathematics, and Coursera may be the best option. So this is something if you want to have a theoretical approach first and then head on to hands-on. So these are two approaches. I would highly recommend hands-on based learning. You can also go and there are other YouTube series like Fast AI. These are communities which have approached the hands-on based learning. They have all their materials free of cost available on YouTube. You can also check Fast AI community. So these are some of the recommendations which I have for learning, but again you will have to find out what is best for you. Yeah.
Thank you, ma'am. We again have another question, and this time it is from the WITS Guwahati community. So I'll actually read that out to you as well. One of our members, like she's from the core team, she actually wants to know about the datathon. Like, there's a lot of notebooks that are available in private. They are, everything is like open source right here. So it's like everyone has some, when they make the submission, it's publicly available. Like, how do you go about that? Like, do you, if you use someone's, a part of someone's notebook, do you have to give them like something like a citation, or do you have to mention it? Like, how do you, just can't take away someone's work, right? So how do you do that?
Yeah. So for this question, the answer is the Kaggle's license. So all the notebooks under Kaggle, if you make it public, then it means it comes under Apache 2 license. So whenever a person is making it public, the person has to be aware that anybody will use that person's work, and especially if it's a CSV based competition or a notebook based competition, also anybody will use that, can use that person's work. And so if you want others to use your work, then you can make it public. If you do not want others to use, and you cannot question them for using it, so this is a condition which is open. So the person who is open sourcing their notebook means they want others to learn from their work and use it. And so you can use any public notebook in Kaggle, and you don't have to give any citation. You just can download the CSV file and make a submission. So this is my output submissions.csv file. You can just download it using this download icon and submit this as such. But if you're going to create a new notebook and reuse some of my code, then ensure you give the citation. So, for example, I've used a particular person's code, then I've mentioned in the references I've used this person's code. Or if you copy somebody's code, then ensure you put it as a comment that your code is copied from this notebook. So, if you're creating a public notebook, then you may, and if you use somebody's code, then you may have to give that kind of a reference section. But if you're going to make a submission, not creating a notebook, but you're just making submission to the competition, you can go to any notebook. For example, the best way to do it is go to Bids Datathon and click on code section, hotness by best score. So any competition, go and filter it by best score. So this is a competition. Open this notebook. So this notebook has got the highest score. Click on this notebook and you can just find out, click on the data. When you click on the data, there is no private data set, so it means you can just go to the data set, click on the data, there's a submission CSV file, download the CSV file and submit it. You can submit it, there is no problem at all. You don't have to give any citation, anything, because this is comes under Apache 2 license, which means anybody can use it. Anybody can use the output of this, and you don't have to give any citation. So any competition in Kaggle, filter it by best score, and then okay, if it's a CSV competition, then download the CSV, upload it. Or if it's just a notebook competition, you can fork the competition, copy and edit, and then you can save it, and then make a submission to the CSV. Make a submission. That is also an option. This is a CSV file. You can directly download the CSV file and submit it. But people who are going to release their solutions like 28.173, and if you go to the leaderboard is 16.468. So 28 is somewhere
Mhm.
way below. So it doesn't matter. Like even if you use a score, the first prize winners, this is not a medal based competition. The competition does not offer any ranking points or medals. So this is a leaderboard. This is just for the first three winners are going to get the prize. And so see, the first three winners in the public leaderboard doesn't mean they're going to be the winner. The shake-up might happen. You don't know who's going to be the winner. But if it's just 28, it's way too below. And so it doesn't matter. Like, even if you just upload the CSV file, you have to do a lot of work to climb up the leaderboard. So you can reuse it and make a submission, but then to climb up the leaderboard to come in top 10, you might have to work hard at least for 20 to 25 days. This is my recommendation. So if you ask me if you can use it without giving citation, yes, you can download the CSV file and upload it. You don't have to mention it anywhere. You can just upload it.
Okay. Ma'am, can you please share your notebooks as well? It'll be a
Yeah,
great
sure.
reference for us to like go about the thing.
Yeah, sure. So this is the first notebook. So I'm just pasting it in the comments section.
I can see weights and biases there.
Yeah, yeah. Weights and biases is used for tracking and machine learning models, and there are a lot of additional features as well. So I've covered some basic features, but this is just for additional knowledge. You can use the basic. You can skip the weights and biases parts if you find it overwhelming and if you're a beginner. But yeah, so this is going to be a starter notebook, and I'll go. Another thing is head on to the tutorials and resources section. There are two videos: video getting started with Kaggle, energy consumption prediction. Click on this tutorials and resources. Both are videos which are recorded by me. So if you're an absolute beginner to get started with Kaggle, you can watch this. It's only 16 to 17-minute video, which you can finish it off in less than 20 minutes. And the second video is again 16 to 70 minutes, which will walk through every section of code again. So there are video tutorials as well, and so I'll share that as well, the resources page. So in addition to this, if you're more in, because this is a two phase competition, if you're more interested in research, then I've also prepared a research notebook, which is this is variable selection networks is introduced in the paper temporal fusion transformers for time series forecasting. I've taken this particular variable selection network alone and I've implemented it. So this is a research paper implementation. So if you're more interested in what kind of research is possible for the phase two, I mean, for the phase one, it's only based on leaderboard. For the phase two, you can submit a research paper. Being students, you'll have a lot of time to collaborate and write research papers. It'll add a lot of value. See, we're getting selected or not, that is different, but just having the opportunity to collaborate and publish a research paper is good. When you go for final year interview, then people will ask you, do you have any publications? So it's not necessary that you should win, and there's no mandate that you should win the competition and all. You can just go ahead, collaborate with few people and publish few research papers. It will add a lot of value to your resume. So if you are targeting a research oriented approach, then a basic step would be this notebook. This is one of the research paper implementation, but there are lots and lots of resources out there which you can Google as well. This is only for your reference, how to get started. So I'll also share this notebook with you.
Yes, ma'am. It will be a great personal use actually. I'm targeting this while going for the datathon. Like I was pretty excited when I saw the data set when it was released, and very happy to see like the new initiative of them bringing in the research paper thing as well, because that's a bit of my inclination here, because I'm very interested in this whole research phase. Like it kind of gets me excited. So I'm looking forward to the research phase. It's not yet started, I guess. The phase
Yeah.
one will be over, then they'll go for the phase two. So the phase two is something that I really look forward to, and like yeah, it's great. I'm actually looking for a team. So yeah, anyone wants to team up, just let me know for the
Yeah,
phase two
good,
part.
good. Best wishes for you, and I'm looking forward to read your research paper. Do let me know once you publish it.
Yes, ma'am. Surely.
Yeah.
Please let me know. I'm not aware. Are you working with someone for this one research phase?
Research phase, I have a teammate. I have like four teams. This is my orange color. So I have, yeah,
Wow.
that's the first thing. So I have four teammates. So I may have to check with them. So for public, if I have to collaborate with a different person, I might have to, if I'm going to use their solution for research paper, then obviously I have to check with my teammates. I can check and I can get back to you. I will
Yes, ma'am.
check with them
That's
if they
like
are interested
anything.
in the
Yeah.
phase two. If they're not interested, then I can team up.
Yes, ma'am. Like it'll be like something straight off a dream, like to collaborate with you with like someone so senior and like a double Kaggle grandmaster from India. Like that's a dream, I think.
Oh, I
So
recently
yeah.
became a triple grandmaster actually.
Oh, wow.
So I became a triple grandmaster
Oh my God,
just
that
last
is
week,
great.
and this is like there are only four quadruple grandmaster, and there are only six triple grandmasters, and all of them were six males. I'm the seventh triple grandmaster, and the only woman right now to
Yeah,
be.
the only women from India.
Yeah, the only women
Yeah.
across the world actually for
Yes.
grandmaster. Yeah,
Like in representing all Indian women's, it's
yeah.
great. Like I'm very happy. I'm just wow. It's great to have you today, ma'am. It's
Yeah,
very
and
nice.
one
Like
more thing I would recommend is see, off late I'm writing a lot of public notebooks, mostly in TensorFlow. All of them are research paper implementations. So
okay,
here I've written another research notebook, probabilistic BNN. There is another notebook called Tab Transformer. This is again, you can also try this for WIDS. It's transformer based architecture for structural data, and a
okay.
lot of research paper implementation are there. You can also go and follow me on Kaggle, and
Mm-hmm.
this is my profile for people. You can just, you'll have a follow button here, which when you open it, and you can give a follow, so you get a notifications of the notebooks which I write. And this week again I'm going to write a couple of research notebooks. So the entire February I'm planning to write 5 more notebooks. All of it is research paper implementation. So if you're, I'll write notebooks only in TensorFlow. And so because I'm a TensorFlow user group organizer and I'm part of GDG Mysuru as well. So my notebooks will be only on TensorFlow and
Okay,
ML research. So if you're
okay.
interested in TensorFlow, then you can follow me. I won't be writing in PyTorch or any other fast AI
Oh,
nowadays
oh
frameworks.
yeah.
So
Yeah, that's what I was actually getting at. Like, I just wanted to show, like, get the confirmation. Are you on PyTorch or not? I actually have done a few work on PyTorch. Like TensorFlow, also I've toggled a bit with that, but mostly I have worked some
yeah,
things in
people
PyTorch. Yeah.
love PyTorch for the ease
Yes.
of use and all that. But since I'm an organizer for TensorFlow
Hmm.
user group and Google developers group, I'm just like, because if I don't advocate it, then who's going to advocate? You know, being an organizer, I should start
Yeah. Yeah.
doing it first. Only then others will follow.
Mm,
So for
mm,
that reason, I'm doing it only in TensorFlow. You can, if you are interested in TensorFlow, you can follow me on Kaggle, and just every week you can check the notebooks which I write. You'll find
mm.
at least a couple of notebooks per week. This week I just wrote a notebook, Tab Transformer. It's a research paper implementation, recent research paper.
Mm.
And again, I think today or tomorrow I'll publish a notebook as well.
Wow. Ma'am, like, when are you planning on like coming, putting out those papers in public? Like, do you have them, or like it's just the code that you have? Like, you just put out a notebook, right? So
No, this
when are you
is
done
like
with it?
existing research paper. I've just implemented the code in TensorFlow, not a
Okay, like,
research paper. It is a research paper which has come out, and some of the research paper might have implementations in PyTorch. I would have
mm,
converted it to TensorFlow. Or
okay.
some of the papers may not have research paper implementation at all. So they would have given their algorithm or something like that, which I would convert it into code. So most of them are research paper implementations, which I take an existing paper and implement it in TensorFlow.
I mean, it's actually also possible to write a paper on that, right? So your implementation can also be an additional paper.
What I can do is I can do some more in addition to what the original author says. Maybe
Yeah.
I can tweak some loss functions. I can tweak some optimizers. I can add. See, there was one
Mm,
paper which came out which is cosine neural networks. It says
yeah.
basic convolutional neural networks. Instead
Mm,
of the convolutional layers, they are just introducing the cosine layer there. So you
mm,
can tweak some. You can take any existing paper. You can tweak few components and then see how the performance is coming, and then you compare it with 5 other different models, how the performance is coming. That's it, paper over. You start with a case study, like a case
mm,
study which is like analysis comparison case study, which is the easiest way to write a paper. So you take any existing research for any topic, like maybe you're dealing with neural networks for deep learning for structural data. Find out all the deep learning for structured data and time series forecasting. Go through all the research work which has come out in the last 2 3 years, and find out something which you can closely connect to, and see what kind of tweaking you can do to the existing architecture. Then see how whether it improves the performance. If it improves, then it's better for a research paper. If
mm.
it improves the performance, then you can start writing, see, you can compare some 10 techniques and how this addition of new features has improved your model and is giving a better accuracy on a benchmark data set. Generally for research papers, they use benchmark data set, but for bits datathon you will have to use bits data set only. And in general, I'm telling any research paper, then you can show how adding these new features, your model is able to outperform the other 10 variations, existing other 10
Yeah.
existing procedure. This is the easiest way to write a research. So start small, start with these easy techniques, and over a period of time, the more and more you read research paper, you will start progressing to the intermediate and advanced level, it will smoothly come out. But when you start, case studies, comparison case studies are the easiest way to get started as well.
Yes, ma'am. Thank you so much. Like, actually, I am planning on something. I have recently done it with topic modeling and basic models from starting from LD8, gone up to like BERT with the transformer model and everything, and the performance that we have been getting. Like, it's a kind of like a case study, you can say, in context to the Indian subcontinent, how we like categorize disaster and stuff, our understanding on disaster and the data that we can obtain from like publicly available sources of like mostly Twitter to find out the public opinion on it. Like Twitter is like the gold mine, right? So it's
Yeah.
the gold mine of public opinion. It's getting everything out of there. So that's actually something that I've been really busy with. And like once I get the project out, maybe I'll just send you my GitHub link or just anything that I could just show you and let me have some of your views. Like, what do you think? And like your expertise on it would be amazing. And I really look forward to that. Once I'm done, like I'm just tweaking up the last few things, just tying the whole thing up. So like you will probably be one of the first people that I just want to see show the project to and just want to know what everything you think about it and things that have gone wrong and just you feel I should tie these things up. So I'm very excited about showing that to you as well. So yeah, it was great. And
I'm so
yeah,
happy that you're dealing with a good analysis, advanced work, and I'm all excited to read your research paper. And so happy that you getting started with research. It will add a lot of value to your resume, and you'll have good control over negotiating your salary in interviews as well. If you have good research publications, you can negotiate really well. So research paper publications are very good, and the kind of job you get as well compared to normal product based companies. You can also compare, you can also become a research data scientist where you will deal with a lot of research. There are a lot of research jobs as well in data science, and you can target those jobs. So it's very good, and best wishes for it. And do send me your paper, and I'm all excited to read it.
thank you so much, ma'am. Like anything, I just get any roadblock or anything. Like you have always been like something a guiding light. Like whenever I just feel go through something and just I just feel what Usha ma'am is doing. Like I just go to your LinkedIn and just see whatever you've been up to, and just it's so much inspirational and just always a push. So yeah, I'll probably keep on annoying you for a little while now till my work is done and I can just get your opinions on it. So yeah, please bear with me, and I hope to like go along with you in this journey, and hopefully we'll be able to do a paper together. I really look forward to that. So
Yeah,
thank you
I'm
so
looking
much.
forward to it as well, and it's my pleasure to work on this and help you out. Do let me.
Yes, ma'am, surely. Thank you so much for taking up our invitation today. Like I wasn't expecting to get you. It's been great a 15-minute breakout session and just being able to host you for today is amazing. Like, would not dream of it. So, thank you so much. I really look forward to more sessions with you. And like the way I feel inspired by you and your work, it has been really amazing. I hope other students who join us or who will join us through your our recordings will also be very inspired by your work and just take up data science and just explore what a great field it is, and just it's open to people from all disciplines, and you just if need to have the passion for it to just join it. So it's been great. Thank you so much, ma'am. I look forward to more sessions with you. Thank you.
Thank you, and I'm looking forward to collaborating and give more sessions as well. It's my pleasure to be associated with the communities. Thank you so much for the opportunity, and thank you so much, Gayatri and the entire university clubs for coming forward. Google Developer Students Club, and best wishes to all of you, and may all your dreams come true. And looking forward to catch you all once again.
Thank you so much, ma'am. Thank you.
Bye bye.
Bye bye.
I'll go out of the chat now. Yeah.
Yes, yes. Okay. Done. I think we're all done for today. We have again another session at 8. So, yeah, after half an hour break, we'll go for our 8 o'clock session. So,
Okay. Is the stream ended?
yeah, I stopped the recording. I think it will be in my drive.
No.
Well,
It will be in your wrap-up session.
oh, sure.
Okay. Uh,